All right, not sure how that got disconnected there, but it did. But we're going to pick right back up. So that's how we do. So let's go back and re-reference the electron rules. The electron rules tell me that I've got 2 electrons in the first orbital. So we're drawing out fluorine. So I've got an electron here, an electron here. I have my second electron shell. It's got 8 electrons that want to fill it. It's going to have all 8 of them here. And I could draw them. I could draw them as dots or negative signs or E minus, but let's just jump right to it. And I know that I have 9 total electrons. So this secondary shell, it wants to house 8, but it only has 7 left over, right? If I've got 2 electrons in the first shell. So technically here, this doesn't have 8 electrons. It actually only has 7 electrons. It wants to hold 8, but it doesn't have 8 total, so it has 7. So here's where we can apply the concept of what's taking place within the electron rules, right? With our electron rules here, it wants to have 8. If it has 8, it is satisfied. It is stable. But it doesn't have 8. It only has 7 in the second shell. So it wants to gain 1. So you could say very, very safely, very comfortably that fluorine is lacking or is deficient in 1 electron in its valence shell. It only has 7. Right? 7, 8, 9. All 9 electrons are accounted for. So in theory, it wants to gain 1 electron to what we'll just say satisfy its valence shell, or its outermost shell, in terms of being stable. It doesn't have 8, so therefore it is going to react. It is going to be what we'll call reactive. So I'm going to do one more. We'll do a little bit of a larger one, and we will move on to bonding here very soon. Hopefully this doesn't shut off like it kicked me off a few minutes ago. So let's do a little more complex one. Let's do sulfur. I'll do it in a different color. There's no particular reason. I'm just kind of chose this one. Kind of random. So number 16, the atomic number, it's going to tell me it's got 16 protons. It's got 16 electrons. Has 0 net charge. And it has, I can find 32 atomic mass minus atomic number. Tells me it has 16 neutrons, so it's going to have 16 neutrons. I'm going to do this a little faster now. And what I can start drawing here is I know that I've got 16 electrons to work from. So, one thing I didn't do in this one here, sorry, I'm just looking back here. I didn't put in my 9 protons and 10 neutrons in the nucleus. Bingo. Let me complete that. I'll do that one first. I'll do that first. So I have 16 protons and I have 16 neutrons. These are both found in the nucleus. I've got my first electron shell. I've got 2 electrons. I have my second electron shell. It is going to have all 8 of its electrons. So 8 and 2 is 10. I have 16 total. Notice that the third shell is only going to have 6 electrons. And as a result of this, because it doesn't have its 8, it's going to say, we'll just say it wants to gain 2 electrons, right? It lacks them for stability. So it's going to be what we'll call, it's going to be reactive. And it's going to want to react. And it's going to do whatever it can to get 2 more electrons.